Hello and welcome back to Calculus 1, section 2.7, definition of the limit at the end, right? We know everything we're supposed to know about the limit except its definition, so here we go. Assume that f of x exists for all x in some open interval containing a except possibly at a. So, the limit x goes to a of f of x equals L is for any epsilon larger than 0, there is a corresponding number delta larger than 0 such that absolute value f of x minus L is less than epsilon whenever 0 less than x minus a less than delta. What you see on the screen right now is the full definition of the limit provided by the mathematician Weierstrass in 1850. Exactly. So this definition uses these letters that you might not encounter before because they are in Greek, right? So epsilon is the lowercase e equivalent, and the delta is lowercase d in Greek letters. And the rest of the symbols and stuff you know. Those of you who would like to learn more and annoy others, right, is you will write this using quantifiers. So for any epsilon larger than 0, there exists delta larger than 0 such that f of x minus L less than epsilon whenever 0 less than x minus a less than delta. There you go. The whole definition in a mathematical notation. So this is how the honors option would see it. You learn this upside down a, it means for all. This inverted e is there exists. And then also there are other things that, you know, for the set that I can use, and it'll be just, you know.
So there's no shorthand for whenever?
No.
Highly upsetting.
Because it's, I haven't seen it used anywhere else except in this one. So no one bothered, I guess. But there are for therefore and technically anything else. Such that is st. If and only if is if. IFF. When you see this in mathematical definitions, that stands for if and only if. Yeah, IFF. So there are a lot of these kind of things floating around. Anyway, let's talk about the meaning of this, and we're done. I'm going to draw a graph. You're responsible to know this graph and understand this graph and maybe explain it, write a paragraph, whatever. X and y, this is the f of x function. And what I'm going to do is show A. So take this value here. So this is my value A. And then this is A plus delta and A minus delta. All of these will produce Y values. The one in the middle is L, L minus epsilon, and L plus epsilon. Hopefully, you see that you are creating some kind of tube, right? You can think of as a tube around A. So what's happening here is you can see the motion, the approach, as delta is getting smaller, right? It's getting closer to A. So as delta is getting smaller for both sides, you see that it's squeezing into A, right? A is stationary. Now you also see that those motions will squeeze here and then they squeeze there as well, right? Do we all see that? So a squeeze here produces a squeeze there, produces a squeeze there, and that's why that's the answer. So the limit of f of x as x goes to A, you squeeze here, squeeze there, it's L. That's the approach from left side and the right side. A minus squeezes this way, goes up, goes up. A plus goes this way, goes down, goes down. So all of the concepts that we talked about are in here. I'm just going to use my arrows from before to show the squeeze. And we have one more graph like this which outlines the does not exist situation. We are going to use our good old friend 1 over x . And we're going to test 0. That's going to be our A. I'm going to have A plus delta and A minus delta. Now, do you see how when we squeeze, you see that we get this, right? Do we all see that? So previous previous there. I stopped talking. The previous graph, when you compressed on x, it collapsed on y onto a point. Over here, when you collapse on x, these guys go apart. They don't collapse to a point. When you squeeze here, this one is going to be there, and then there, and then there, and then there, and it's going to go up forever. And the one on the other side is going to be here, 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 here. It's exactly what you detect in your chart when you do your values. Remember the values we had in the question at the beginning of the class? When we said it was negative 74, negative 704, negative 7004. Well, that's your 74, 704, 7000, right? You see, that shoots to infinity when you have that kind of increase in values. It shoots to infinity. And this one will shoot down, this one will shoot up, and they're going to be infinitely far apart. So over here collapses into a point, limit exists, and it is L, which is the finite value which we get in our definition. And over here the squeeze on X produces infinite separation. In this case, it could be finite separation as well. It's separation. It doesn't collapse to a point. And that gives us the wrong. That does not exist. And that's it. Hope you're not disappointed. What do you need to know? You need to know these two graphs and to explain these two graphs, and you also need to know the statement itself. All right, ciao. Cool.